Good morning, evening, or whatever part of the day. My name is Alexei, and I'm not a YouTuber, or at least not yet. I went into this as a personal project, and seeing the result, I thought it would be useful for other people in the same situation. A little bit of history of this project. One day, I went shopping at the besieged supermarket, and the old 3M face mask that I had at home just broke in the middle of the trip. I've tried to buy one, but there were no masks anywhere. People were using whatever they could get. So I returned home, determined to copy the 3M for my next shopping day. But when copying the pattern, I realized that I do not have enough material or the right dimensions. There are too many seams, and overall, that design is too complicated and not optimal to make at home. I had a spare cabin filter, some cloth, and other materials. I have a 3D printer, but I have almost no thread left. I get down to work to create the right pattern, or at least a better one. And 13 versions later, this is the result. Objectives and requirements for this project. First, this face mask needs to be efficient. It needs to be a simple pattern, as compact as possible, but very ergonomic. It needs to be reusable and therefore with valve. The valve allows the filter to stay dry. It needs to be adaptable to all kinds of materials that can be found at home. It needs to spend the least amount of 3D printer plastic because I do not have much. And if it's possible for it to be customizable and not too horrible aesthetically. It is not homologated, but I can assure you that it keeps the perimeter and the valve well sealed. Its level of protection would be approximately equivalent of that of FFP2, depending on the materials used. In any case, it is sufficient for the supermarket queue. So, let's start. First, we're going to manufacture the filter body of the mask. First, print the pattern included in the PDF at the 100% scale. That size will fit the vast majority of faces. In my case, I found a car cabin filter that was at home. It is a remarkably stiff synthetic fiber and large enough to make 11 masks. If you can't find anything similar, you can use a 120-gram printer paper or cardboard. In this case, the material does not let air through, therefore it will have to be perforated. It is also possible to use a regular printer sheet, add another layer of fabric or lining, and remove the printed sheet once the mask is built. The result is a more flexible mask, which is likely to last somewhat less. Let's transfer the design of the pattern to the material that we are going to use for the inner support of the mask. It can be drawn on a window, but I use a kind of light table. It's more comfortable to do it this way. Now, cut the pattern. It is time to choose a fabric for the outside of the mask. It has to be a fabric that perspires enough not to make it difficult to breathe, preferably synthetic in the color that suits you best. I do not recommend too thin or too stretchy fabrics because they are more difficult to work with. Iron the fabric properly. Present the pattern and draw a perimeter approximately 1.5 centimeters or 2 apart, depending on the skill you have folding and sewing. Cut out the drawn perimeter. It is not necessary to cut the central semicircle yet. Now it's time for the main filter element. I am using kitchen paper because it is what I have. It is relatively strong and filters very fine particles. In fact, it does wonders by filtering the frying oil. Paper tissues, napkins, dishcloth will surely be worth. Next time I think I will do it with this dishcloth. Well, in each case, you will have to experiment with the materials and the number of layers, the thickness of the filter, so as not to make breathing too difficult. I use 3 layers of kitchen paper. I've tried 4, but it's more uncomfortable. The napkins are slightly smaller than the pattern and do not cover it completely. But it does not matter because precisely this part is the nose piece. There is no need for a filter here. Now cut all that. There is no need to cut the center semicircle yet either. Let's put the whole sandwich together. Now it's time to prepare it for the sewing machine. If you do not have a sewing machine, well, to glue it together. I usually start to fold from the bottom, then securing the top folds so the sandwich doesn't move too much. Next is folding and ironing the corners. The part near the nose piece is a bit tricky. You have to fold this part away from the corner first, so the second fold doesn't overlap. If you do so, it will be easier to sew and you will have less opportunities to break the needle. Also, the piece will come out better finished. To the sewing machine! I usually start the seam at this corner, nothing fancy. Simple, straight seam. Make the straight seam towards the semicircle. Rotate and make the semicircle slowly. At least I do it slowly. If someone is awesome enough to do it at 200 miles per hour, cheer up. Complete the perimeter at the appropriate speed for the road circumstances. Let's talk about the leash. I have found these elastic bands at home. At first, they seemed too wide to me, but cut to the right size, they are very comfortable. The length of the headband may depend on the size of your head and the elasticity of the headband. But from what I have checked, about 37 to 38 centimeters is the right length, so most heads do not get too tight. But if you like it tighter, you can cut it to 35. The junction point is in this corner approximately, perpendicular to this edge, at the right angle sort of. A 5 mm wide zigzag seam and the same on the other side. Now the semicircle can be cut out. Now the most complicated sewing. In order to make it easier and more precise, I resorted to the glue trick. Choose the side that is nicer finished and apply the glue on the other side, as well as on the reverse side of the opposite side. Wait a bit for it to dry. Join both parts and massage the joint with some love for a minute or two. It is now much easier to sew. 5 mm wide zigzag seam all the way down, sew forward, sew backwards, forward and finish off. It is already taking shape. In order for the mask to hold tightly to the nose and guarantee the perfect seal of the perimeter, a good nozzle piece must be made. In my case, I use a can of anchovy-flavored olives. Cut a piece of can with approximately this shape. Finish off the corners so as not to prick ourselves. Now you have to find something padded. In my case, I found a piece of felt that is ideal. Look for something similar, a piece of foam, something like that. Cut the felt, reserving the space around the nozzle spring. Apply glue here and there, let it dry, joined. After it's dry, fold the spring slightly in the middle, hold out next to the mask. It has to enter like this. Apply glue for what will be the inner part. Put together for a moment, reapply glue where needed, wait. Join the piece taking care that is centered. I personally like to let the padding protrude a couple of millimeters from the edge of the mask. Massage a couple of minutes with great care and love so that the piece is well glued. Finally, it's time to make the shape of the nose by folding this part along the line marked in the pattern, approximately, which of course, depending on the shape of your nose, you can adjust to your whim. We are almost there. It only remains to manufacture the valve. If you have a 3D printer, you can print the attached file in the description. If you do not have a 3D printer, you can adapt a soft drink or mineral water bottle cap or similar. I have not tried to make that adaptation because I do not have any bottle of soda on hand. But there is the idea. It is likely that you will have to reduce or enlarge the size of the semicircle of the pattern so that it fits well with the diameter of the bottle cap you are going to use. Drill a few holes in the center, remove the resulting burrs, and leave the surface perfectly smooth. Well, here are my pieces straight out of the oven. Impressive, they are already painted. This valve design has two pieces, the base with a grid and the cap. I'm using a kitchen glove to manufacture the membrane. The one I have at home is perfect for that. We only want the smooth parts of the glove, not the bumpy textures. Draw a circle that is slightly smaller than the diameter of the valve base, so that it covers all the holes without reaching to the edge. Once a circle is cut, degrease it, apply a drop of glue, another on the valve base, trying to get a thin layer. We do not want a fat drop that leaves the membrane, letting the air pass. More or less centered like this. There it goes. If you have talc, it is a good idea to sprinkle a little bit of it on the rubber so it does not stick when not in use. Now we just need to connect the valve to the rest of the mask. Apply glue to the inside of the valve base, also around the hole in the mask. It is advisable to look toward where the valve opens to mount this part facing down, which is the direction in which it is desirable to expel the air, downwards. Wait a bit, delicately join both pieces by repeatedly pressing around the perimeter. Check for its correct operation. Great! It is time to put the valve cap. Well, not like that. Better. The cap is designed to be interchangeable. I have included a couple of designs that you can modify if you wish so. But if you do not intend to change caps, this can be glued. To disinfect the mask on your return from your allowed by the competent authorities walk, you can use a cotton swab moistened with alcohol. Do not wet the mask with alcohol. It is not necessary. It can be damaged. Well, I hope that was useful to you. I'm doing a small series of masks for myself and for my friends. And if you are lucky to find enough material, you can also collaborate making a few for your closest circle. Thank you, dear viewer, having reached the end of this video. I look forward to your contributions in form of improvements, suggestions, or simply by sharing your experience of the make. The end!